Good morning, Stingrays! Today is, don't worry about it actually, because what I'm going to be doing is making up for some of those lost videos I didn't do from when I had to be home for during, So, here we go. I'm going to start off with technically the lesson was area of a parallelogram, but I'm going to go over the entire quadrilateral family, okay? So, quadrilateral means that it has four sides. It means more than that, okay? Let's just start with the basics. Our old friend quadrilateral right here. This one we've always known. Mr. Square. We've known this guy since kindergarten. Probably even sooner than that. What a square is four sides that are exactly the same. So 5, 5, 5, 5, and 5. Okay? They also all have the same angle on the inside. 90 degrees. So 4 similar sides, 4 similar angles. Let's move over to its cousin, the rectangle. The rectangle is essentially a stretched out square. It has 4 angles that are 90 degrees, just like a square, but here's the kicker. These two sides are the same length, and these two sides are the same length. That's what's different. It doesn't have 4 sides that are exactly the same. It has 2 sides and 2 sides. Now let's keep going on to what our lesson's about, parallelograms. Parallelogram is the distant second cousin of the rectangle. It is essentially a rectangle that has been tipped over. All it's done is it's lost it straight up and it's tipped over a little bit. And here's what makes it a parallelogram. It's just like a rectangle in that this side and this side are exactly the same. This side and this side are exactly the same. The numbers are going to be exactly the same. But the angles are different now. These angles are going to be exactly the same, and these angles are going to be exactly the same. Just like the rhombus is just like a square. The rhombus is essentially a square that's been knocked over. So it has 4 sides that are actually the same exact side, just like a square. But instead of having 4 angles that are all the same, these angles are the same, and these angles are the same. So that is basically the quadrilateral family. There is technically one more, but he doesn't apply for what we're about to learn right now. So, probably a couple years ago, you learned what the area of both of these are. And you learned that it was length times width. Awesome. I'm going to change that saying. Length times width. That's what you learned. I'm going to change it. Let's change that now to base times height. Base times height. So that when we move on to 3D objects, you have a better understanding of what's what. Base times height. Same thing over here. Base times height. Now, what makes quadrilaterals a family is that it doesn't change. Okay? Area of a parallelogram and area of a rhombus is still base times height. So over here, base times height. Base times height. Same exact things. Did not change. Okay? The way to find an area did not change, but here's the thing that changed for these guys over here. Mr. Parallelogram, Mr. Rhombus. Where's the height? See, over here, rectangle, the height's obvious, straight up and down. But over here, I would never measure your height while you were like slouched over. Okay? I'd tell you to straighten up or get the best straight angle I could get. So what you're going to get is usually always it's going to be a dotted line through the middle here telling you what the height is. So that's where your height is. And the same thing over here with the rhombus. You'll get something over here that says height. So this is still your base, is the bottom. This is still your base on the bottom. But now your height is in the middle to tell you essentially how tall the rectangle is, even though it's leaned over. So quadrilaterals, the lesson we're focusing on is parallelogram. The way to tell the area did not change from its friends, the square and the rectangle. It is still the same thing, base times height. Just be aware of where the height is. You might get problems. Well, they'll put the number here. Like this will be 6. This will be 12. But this will be 5. That's not the height. Okay, they're trying to trick you. You know what the height is. It's right here. 12 times 5, 60. Not 12 times 6. 72. Yeah? Yeah. Okay, so that was the area of a parallelogram, which is technically the lesson of this, this section. All right, I'm going to try and make a bunch of videos for tomorrow's review.